Have you ever looked at a rainbow after the rain and wondered, how does white light turn into all those colors? Or watched fireworks burst in the night sky and think, why do they explode in different colors like red, green, and gold? Well, guess what? Behind every color you see, there's chemistry, where molecules paint our world. And trust me, by the end of this video, you'll never see colors the same way again. First, what is colors in the first place? Color isn't actually a property of objects. Color, at its core, is how our eyes interpret different wavelengths of light. But the real magic happens in the matter, the atoms and molecules that absorb, reflect, or emit that light. Everything around us is made of atoms, and atoms have electrons, tiny particles that orbit the nucleus. When light hits a material, these electrons can absorb energy and jump to a higher energy level. But they don't stay there. They fall back down, and when they do, they release energy, sometimes as light. And that light? That's the color we see. Light is made up of many wavelengths, each corresponding to a different color in the visible spectrum, from violet at around 400 nanometers to red at about 700 nanometers. For example, a leaf appears green because it reflects green wavelengths and absorbs red and blue. So, why do different objects have different colors? It comes down to molecules and how they interact with light. The main players here are pigments and structural colors. Pigments are molecules that absorb specific wavelengths of light. For instance, chlorophyll in plants absorbs red and blue light, leaving green reflected. Structural colors aren't due to pigments at all. Instead, they're created by microscopic structures that bend and scatter light, like the shimmering wings of a butterfly or the metallic blue of a peacock feather. So, whether it's a ripe tomato, a dazzling gemstone, or the glow of neon lights, it's all about how matter manipulates light. How exactly does chemistry create color? It starts at the atomic and molecular level. When light hits a molecule, electrons can absorb certain energies and jump to higher energy levels. They can only absorb specific amounts of energy, so only certain wavelengths get absorbed and the rest are reflected. That's the color we see. In organic compounds, color often comes from something called a chromophore, a part of the molecule with alternating double and single bonds. This structure allows electrons to absorb light in the visible range. For example, beta-carotene in carrots absorbs blue light, so we see it as orange. Anthocyanins in flowers and fruits can appear red, purple, or blue depending on pH. That's why hydrangeas can change color in different soils. And it's not just pigments in inorganic compounds. Metals can create vivid colors too. The green of emeralds comes from chromium atoms. The blue in copper sulfate is due to copper ions interacting with water molecules. Now, here's the fun part. Some colors change depending on temperature, light exposure, or chemical reactions. That's called thermochromism, like mood rings, or photochromism, like UV-sensitive sunglasses. So, what's the point of all this color chemistry? In nature, color plays critical roles. Attraction flowers use bright pigments to lure pollinators. Camouflage animals blend into their surroundings to hide from predators. Warning: bright colors in frogs or insects signal danger or toxicity. In human use, color chemistry is everywhere. Food industry, artificial and natural colorants make products more appealing. Textiles and paints, dyes and pigments bring fabrics and walls to life. Technology screens, LEDs, and lasers all rely on precise control of light and color. Medicine color-changing indicators are used in tests and diagnostics. Even art owes its vibrancy to centuries of experimenting with minerals, plants, and synthetic pigments. So next time you see a rainbow, a glowing jellyfish, or even a colorful candy, remember, behind that beauty is a hidden language of molecules, light, and chemistry working together. The world is colorful because chemistry makes it so. Let me know in the comments what your favorite color is. See you in the next video.